Right, g'day junior techies, my name's Mr. P. I'm going to be taking you through this video dealing with question 4 of the worksheet of the breathing system, okay, or the respiratory system. So we're going to be looking at question 4. So if you haven't yet got the worksheet or the worksheet memorandums or the theory booklet, please make sure that you get your hands on those. They're going to be fantastic in helping you prepare for your final exams. Okay, let's dive right into question 4 now. So let's have a look quickly in doing a question analysis here. So question 4 says an investigation was carried out on a person in which the volume of air taken in at each breath and the number of breaths per minute were measured at rest and after running. And the results are shown in the table below. So here we see that the volume of air per breath, so this is now the depth of breathing, at rest is 450 cubic centimeters, and after running is 1000 cubic centimeters. So we can see a definite increase in the volume of air being breathed in when comparing rest to exercise. If we look at breaths per minute, so this is now the rate of breathing, we see that at rest we've got 20 breaths per minute and after running 38. So there is definitely an increase in the number of breaths per minute. So if we see, what is this data actually telling us? This is telling us that there is definitely an increase in the physiological demand on the body when moving from rest to exercise. Okay, so we haven't looked at the questions yet. We're first getting some context from the data that we've been given. And that is so important in life sciences. It makes answering the questions just so much easier. Right, so let's have a look at question 4.1. Okay, this is an explain question. That means we need to be identifying the what and the why in the context of our answer. So it says, explain why the amount of oxygen taken up into the blood increases after exercise. So it's about oxygen taken up into the blood, obviously, through the breathing system after exercise. Why is there an increase? And we need to explain what has changed and then why is this necessitating an increased uptake of oxygen. So if we look at answering this question, this is because there is an increase in cellular respiration. That should be an obvious. Okay? The amount of oxygen taken up by the blood increases after exercise because there has been an increased demand for it through cellular respiration. Okay, so there will be either a 2 or a 3 mark question here. So we can see that increased cellular respiration necessitates an increase in breathing rate, and therefore an increase in the uptake and delivery of oxygen to the muscles. Okay, so that's a 3 mark question, and I think if our answer encompasses each of the things we've listed here, so an increase in cellular respiration increases the need for increased breathing rate, which delivers more oxygen to the muscles that are respiring. I think we're going to get our 3 marks there for question 4.1. Right. This is also going to be a necessity, or there will be an increase in the necessity for the removal of CO2. So not only the delivery of oxygen, although this is what the question is about, the oxygen delivery, but with an increased breathing rate, we're also going to have the increased removal of carbon dioxide, which is an important point not to forget, although we might not get a mark for that in our answer here. Okay, let's look at question 4.2 quickly. This is a describe question, not an explain question. That means we just need to look at the data and identify the data. So describe the changes that took place in the human body to bring about an increase in the breathing rate of a person. So what's actually happened here? The control mechanism that would result in an increased breathing rate. Right, give that a minute, have a think about it. What are we talking about? We're talking about the control mechanism. So, increased cellular respiration results in an increased production of CO2. That means there's going to be a higher concentration of carbon dioxide collecting in the blood. Obviously, the CO2 comes from that respiring tissue in the body, and it collects in the blood, and it needs to be gotten rid of. The body needs to excrete this byproduct of cellular respiration. And how does it do that? Okay, this is going to bring about, so this increased CO2 concentration is going to bring about a decrease in the pH. Now this is the power of hydrogen. This basically means that there is going to be an increase in the acidity of the blood. The decrease in pH is actually an increase in acidity. This is picked up by receptors in the body. So chemoreceptors in the carotid artery, they're stimulated by this increase in acidity. Impulses are generated, and then the impulses are sent to a control center. Okay? And the control center here is the medulla oblongata of the brain. So the medulla oblongata receives these impulses that say there is an increase in the acidity of the blood, and the medulla oblongata now needs to manage this. It then sends impulses to the intercostal muscles and the diaphragm to increase the rate and the depth of breathing. Okay, now this is the control mechanism for breathing. So if we look at question 4.2, here we are describing the process. So the changes that took place in the body to bring about an increase in the breathing rate. Increase in cellular respiration increases CO2 concentration, decreases pH, increases acidity. Chemoreceptors pick up on the increase in acidity. Impulses are sent to the medulla oblongata, which is the control center of breathing. Medulla oblongata sends impulses to intercostal muscles and diaphragm to increase the rate and the depth of breathing. And this is how the control mechanism works. If we look now at question 4.3, we'll answer that at the top there where we've got a bit of space. 20% of the air breathed in consists of oxygen, but only 16% of the air breathed out consists of oxygen. Calculate the amount of oxygen entering the blood per breath after running. Now we're going to be using the data that we get given in the table, and we're going to be doing our calculation. So I would suggest we get our data sorted out first. Okay, and that's what we see up at the top over here. All right, we see 20% in, 16% out. That gives us a 4% difference. All right, if we look then at what this means, that 4% is moving into the blood. Question asks us, calculate the amount of oxygen entering the blood per breath after running. So if we look at the volume that this represents, after running, we've got a volume of 1,000 cubic centimeters, and we're multiplying this by 4%. That will give us the answer in volume of air, which is 40 cubic centimeters. All right, and that's a 3-mark question. So for all of our calculating over there, we're going to be getting our 3 marks. And there's a total of 11 for question 4. Well, I hope that in us going through this question together in this video, it's helped you better understand how to analyze exactly what the questions are asking us to put in our answers to make sure we get full credit, because that's what we want. We want to do well at the end of the year. And I do hope that this video has helped you. Again, if you don't have that worksheet and worksheet memo, get your hands on it, practice those questions, and tune into some of the other videos that we have available for you so that we can help you prepare to do your best. All right, Junior Tickies, thanks a million. Have a great afternoon.